we're told that the rod is in equilibrium. In this case, equilibrium means that there is no resultant force. In other words, this rod is going to have no tendency to accelerate either upwards or downwards. But also here, equilibrium means that there is no resultant moment. In other words, there is no resultant turning effect on the rod. Considering the fact that there is no resultant force means that our one force that acts downwards, the x, must be equal to the two forces acting upwards. So x must be equal to 18 newtons. So this is 18 newtons, and we can now use the fact that there is no resultant moment. This would be the case about any pivot. I'm just going to use the pivot given to us. Taking moments around this pivot, first consider the 18 Newton force pulling downwards here. This is going to pull us clockwise. The 10 Newton force pulling upwards is also going to be clockwise, and the 8 Newton force pulling this way will turn us anti-clockwise. Since there is no resultant moment, the sum of the clockwise moments must be equal to the anti-clockwise moments. Therefore, they cancel out. So, if we look at this situation, our clockwise moments, we have 10 times 2, and we also have the 18 times d. For the anti-clockwise moments, we have the 8 at a distance of d plus 3. So we need to solve this equation. We have 20 plus 18d is equal to 8d plus 24. This gives us that 10d is equal to 4, and so d is 4 divided by 10, which is 0.4 meters.